and differential noise. By the end of this video, you will be able to rectify the clutch slip, clutch binding, hard clutch and gear slip, and rectify noise in the clutch and gearbox, propeller shaft, universal joint and rear axle. Let us collect the tools and equipment required to do this exercise. Trainees Toolkit 1, Feeler Gauge 20 Blades Metric 1, Circlip Plier 1, Heavy Vehicle 1, Kerosene as required, Bunion Cloth as required, Grease as required, Cleaning Tray as required, SAE 90 EP or 140 oil as required, and soap oil as required. Rectify the clutch slip. Check the following. Pedal free play, adjust if found to be too little. Clutch finger, adjust if found wrongly adjusted. Clutch plate reline if found worn out. Pressure plate, flywheel face, reground or replace if face out is excessive. Pressure spring, replace if found weak. Rectify the clutch binding. Check the following. Linkages for bend, remove or replace if bends are found. Pedal free play, adjust if found excessive. Pressure plate or flywheel, replace if found cracked. Clutch plate, replace if found cracked. Clutch fingers, adjust if not adjusted correctly. Hard clutch, check the following. Linkages, remove or replace if bends are found. Joints, lubricate if not lubricated. Gear slip, check the following. Gear level and selector rod adjusted if not adjusted properly. Lock spring, replace if found weak. Locking ball pin, replace if found worn out. Rectify the noise in the clutch. If the noise is in the clutch assembly, the symptom is that the noise is heard while engaging the clutch. Causes could be insufficient pedal play, improper clutch lever adjustment, seizure of thrust bearing and release levers, broken or weak fork lever return spring, excessive clearance in driven plate hub and clutch shaft spleens, dry or dirty clutch linkages. Remedies: they need to be adjusted, readjusted, rectified or replaced or cleaned and lubricated. Noise in the clutch assembly. Symptom: continues to make noise but noise disappears when the clutch is disengaged. Noise is in the engaged position. The causes: misalignment of engine and transmission which needs to be realigned, friction disc torsion springs which are weak or broken, where we replace the clutch disc, friction disc hub and clutch shaft spleens worn out, so they have to be replaced, weak or broken pressure springs which can be replaced, weak or broken anti-rattle springs which can be replaced, pilot bushing in flywheel worn out which can be replaced, cracked pressure plate or flywheel which can be replaced, fulcrum of release bearing holder damaged which can be replaced. If there is noise in the clutch assembly, the symptom is continuous noise in both driven plate hub when it is in engaged and disengaged positions. The causes: worn spleens on the clutch shaft which can be replaced, friction disc damper springs are broken or weak which can be replaced, misalignment of engine and transmission which can be realigned, worn or dry clutch release bearing which can be replaced, release levers not properly adjusted need to be readjusted, pilot bearing in crankshaft worn or dry need to be replaced, retracting spring in a diaphragm spring clutch if it is worn out needs to be replaced, loose release fork mounting needs to be tightened, and if the release levers striking clutch cover, if they are defective, they need to be rectified. Noise in the gearbox. If there is noise appearing in the gearbox neutral position, the symptom can be that the noise is appearing in the gear neutral position. Causes: worn or dry clutch shaft bearing or spigot bearing which can be replaced, worn out gear TTs can be replaced, too much end play in the countershaft or gears can be adjusted, worn out or dry countershaft gearings can be replaced, transmission misaligned with the engine can be realigned, too much backlash in driving gears in between gear vehicles can be replaced, insufficient and wrong lubricant type, there the change of oil is recommended, gear shifting forks rubbing in grooves can be adjusted. If the noise is appearing in the gearbox, the symptom is that the noise is appearing when the gear is engaged or in a particular gear. Causes: worn, chipped or broken gears which can be replaced, lack of lubricant which needs to be topped up or flush and refill with correct grade of lubricant. Countershaft gear worn out or damaged can be replaced, gear loose on the main shaft can be replaced. If there is noise appearing in the gearbox, then the symptom is that the noise is appearing when the gear is engaged or in particular gear. The causes are damaged or worn out synchronizer ring gear which can be replaced and counter gear or bearing worn out or damaged which can be replaced. If there is noise appearing in the gearbox, the symptom is that there is noise in all the gears. Causes: transmission misaligned with the engine case can be realigned, speedometer drive gear damaged can be replaced, input shaft bearings worn out or damaged can be replaced, low oil level can be topped up, main shaft rear bearing worn out or damaged or dry can be replaced. If there is noise appearing in the gearbox, the symptom is that the noise comes while gear shifting. Causes: clutch not disengaging, the clutch pedal free play is excessive which can be adjusted, idle speed which is excessive can be adjusted, shifter fork bend can be rectified, gear shift linkage out of adjustment can be adjusted, idle speeding of engine when is too high can be adjusted, incorrect lubricant can be replaced, shaft spleens and gear teeth worn out can be replaced, interlocking device linkage out of adjustment can be readjusted, and the shifter lock springs, if they are too strong, can be replaced. Rectify the noise in the propeller shaft and universal joint. If the noise is occurring in transmission drive line or the propeller shaft and universal joints, the symptom could be that the noise is heard only in the initial movement of the vehicle. Causes can be loose flanged yoke of universal joints or bolts are loose which can be tightened, worn out propeller shaft or slip joint spleens due to lack of lubrication can be replaced and lubricated, worn or damaged universal joints can be replaced, needles in the bearing short in numbers can be replaced. Another symptom is that the noise is heard when the vehicle is running. The causes for this could be loose or missing bolt at the center bearing support where we provide a new bolt and tighten it, bent propeller shaft which can be replaced, center joint bearing and support rubber pad damaged can be replaced, shaft rubbing on parking brake cable where they position the brake cable correctly, unbalanced propeller shaft can be replaced, joint or shaft hitting the frame of the vehicle where we use shims to lift it up, lack of lubricant in U-joints, also in spleens of propeller shaft and slip joints can be lubricated with grease. If there is noise occurring in the differential, the symptom could be that the noise is occurring in the rear wheels. Causes could be worn out or dry hub bearings which can be replaced or lubricated, bent or twisted axle shaft which could be set right, excessive axle end play which could be adjusted, bent wheel that can be replaced, loose rear axle nut can be retightened, lack of lubricant on the axle bearings where it can be lubricated with grease, and loose wheel nuts can be retightened. Rectify the rear axle noise. If the noise is occurring in the differential and rear axle unit, The symptom is that the noise occurring when the vehicle is running straight ahead. Causes could be low oil level in the differential, which could be filled up to the level. Excessive backlash on crown wheel and pinion can be adjusted. Worn out drive pinion and crown wheel where we change the pairs. Loose crown wheel bolts can be tightened. Worn out or damaged differential case bearings can be replaced. Worn out drive pinion bearing can be replaced. Improper drive pinion and crown wheeling adjustment can be readjusted. Another symptom is that there is noise on turns. Causes could be pinions or sun gears that are damaged and can be replaced. Pinions or sun gears loose need to be replaced or adjusted. Backlash between the pinion and star gears excessive, where we can reduce the adjustment by referring to the manual. Axle shaft end play excessive can be adjusted to correct clearance. Pinions binding on shaft can be rectified. Damaged surfaces between sun gear and differential case can be replaced. Worn out sun and star gears and thrust washers can be replaced, and slack or rough hub bearings can be replaced. By the end of this lesson, we have learned to rectify the clutch clip, clutch binding, hard clutch and gear slip, and rectify noise in the clutch and gearbox, propeller shaft, universal joint and rear axle. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, let us identify the automatic transmission components, check the fluid level and replace the filter in automatic transmission. By the end of this video, you will be able to identify the various parts of the automatic transmission, check the transmission fluid, remove the old fluid and filter and fill the new fluid and fix the filter. Let us collect the tools, machinery and material required to do this. Trainees toolkit 1, ring spanner set 1 set, socket spanner set 1 set, hydraulic jack or ramp 1, vehicle with automatic transmission 1, tray 1, bunion cloth as required, transmission fluid as required and filter 1. Identify the various parts of an automatic transmission system. Cover assembly, clutch transfer ring, shoe assembly, washer, pressure plate, plate, inner race, roller assembly one way, drive hub, end cover, spring, turbine assembly, reactor and clutch assembly and the impeller assembly. Remove the old fluid and filter. Start the engine and ensure that it is as warm as required. Stop the engine and check the oil level. Use the jack to lift the vehicle or park the vehicle on the ramp. Also, we can use the 2-post hoists to lift the vehicle. Drain the old oil by loosening the drain plug. If the oil pan does not have the drain plug, then remove the bolts from the oil sump one by one. Slowly drain the old oil. Remove the oil filter by rotating counterclockwise or removing the clips or O-rings depending upon the model. Fill the new fluid and filter. Fix the drain plug in its place. Measure the oil as recommended by the manufacturer. Pour the oil. Measure using dipsticks. Start the engine and warm up for a few minutes. Again, check the oil level. If satisfactory, then run the vehicle. In this video, we have identified the various parts of automatic transmission, checked the transmission fluid, removed the old fluid and filter and filled the new fluid and filter. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, let us learn the oil pressure control cable play adjustments, inspect the shift lever switch, throttle position sensor, speed sensor and the automatic transmission wiring harness coupler. By the end of this video, you will be able to adjust the oil pressure control cable play, inspect the shift lever switch, check the throttle position sensor, speed sensor and check the automatic transmission wiring harness coupler. Let us collect the tools, machinery and material required to do this. Trainees toolkit 1, box spanner set 1, Allen key set 1, torque wrench 1, multimeter 1, 12 volt battery 1, light motor vehicle 1, cleaning tray 1, lubricant 1 and bunion cloth or as required. Adjusting the oil pressure control cable play. Ensure that the vehicle is parked on a level surface and the parking brake is engaged. Measure the current play in the oil pressure control cable. Use a tap measure or ruler to determine the distance the cable can move before engaging the transmission. If the cable has an adjustment nut or clamp, use the appropriate wrench or screwdriver to loosen it. This allows for adjustment of the cable length. After adjusting, start the vehicle and test the transmission operation. Shift through the gears to ensure smooth transitions. Pay attention to any unusual noises. If the transmission operation is not optimal, fine-tune the cable adjustment. Make small adjustments and retest until the desired performance is achieved. Inspect the shift lever switch. Check the position of the power change mode lever for damage. Check the gear shift lever sensor's wire connection. Check the gear lever movements in the manual operation position. Change the lever position to automatic transmission and check the automatic speed of the vehicle. Check the panel board light signal of the gear position. Checking the throttle position sensor. Remove the air cleaner assembly. Turn off the ignition switch. Disconnect the connector from the electric throttle body. Check the TP sensor main and sub output voltage as follows. Arrange 3 new 1.5 voltage batteries. Connect the voltmeter and battery to the TP sensor. Check if the voltage linearly varies depending on the throttle opening angle while the throttle valve is opened and closed using a finger. If there is no reading or the reading varies abruptly, then the sensor must be changed. While testing, the following conditions need to be fulfilled. The ambient temperature should not exceed 5 degrees Celsius. The accelerator pedal should be in the idle position and the throttle should be fully closed. Checking the automatic transmission wiring harness coupler. Check the wiring harness coupler continuity using a multimeter. Check the coupling points and the automatic transmission control solenoid. Check the transmission wire harness connectivity for its functionality. Checking the automatic transmission safety switch. automatic transmission safety switch gear selector switch, automatic transmission safety switch kick down solenoid, automatic transmission safety switch speed sensor, automatic transmission safety switch EH gearbox switch, automatic transmission safety switch gear position sensor, and automatic transmission safety natural safety switch, automatic transmission safety over drive kick down switch, automatic transmission safety control solenoid module, automatic transmission safety position selector switch, and automatic transmission safety pulse generator sensors. In this video, we have discussed how to adjust the oil pressure control cable play, inspect the shift lever switch, check the throttle position sensor, speed sensor, and check the automatic transmission wiring harness coupler. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to troubleshoot issues with the suspension system, identify causes, and provide remedial solutions. By the end of this video, you will be able to troubleshoot issues in the suspension system, identify causes for the issues, and provide remedies for the issues. Wheel hop issues are usually due to the bending of the rim caused by uneven tire pressure or overload, improper tire settings or incorrect alignment, the impact of low tire pressure, and loose or broken wheel mountings. The possible remedies include rectifying the rim bend, ensuring correct tire pressure, tightening or replacing the wheel mountings promptly. Defects in the vehicle's ride height are caused by weaker leaf spring tension, broken leaf spring hanger or hinges, uneven tire pressure, damaged shock absorber bushes. The possible remedies include increasing the temper of the leaf springs, replacing damaged hangers, ensuring correct and even tire pressure, and replacing damaged shock absorber bushes. Excessive travel and bounces to the suspension system can be caused by weaker leaf spring tension, broken center bolt and leaf spring hanger or hinges, damaged bounce stop, loose or damaged wheel bearings. The possible remedies include increasing the temper of the leaf springs, replacing the center bolt or leaf spring hangers or hinges, replacing the damaged bounce stop, replacing the defective wheel bearings. Fluid leaks can be caused due to cracked pipelines and union or loose union threads. Noisy suspension during operation can be caused due to dry lubrication, worn out or loose hanger pins and center bolt, and faulty shock absorber. The possible remedies for fluid leaks are replacing cracked pipelines and unions, tightening loose unions. The possible remedies for a noisy suspension are lubricating suspension pins, hangers and springs periodically, inspecting and replacing defective center bolts and hanger pins. Worn dampers and joints can be due to dry lubrication, loosening of the damper pad, or over-tightening of joints. Vehicle crabbing can be due to uneven tire pressure, improper toe-in, broken main leaf spring, or worn-out kingpin bearing. Possible remedies for worn damper and joints are proper lubrication, avoiding over-tightening of joints, and tightening damping pads. Possible remedies for vehicle crabbing are as follows. Check and set tire pressure evenly. Inspect and correct wheel alignment. Inspect and replace damaged main leaf and kingpin bearing. In this lesson, we have learnt to troubleshoot issues in the suspension system, identify causes for the issues, and provide remedies for the issues. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to check and repair both tube and tubeless tire puncture. By the end of this video, you will be able to dismantle the tire and remove the tube, locate the puncture, apply patching cement on the puncture spot, and assemble and inspect the tire and the tube. Let us look at the required tools, equipment, and materials. Trainee's toolkit 1, tire lever 1, hammer 16 pounds, wood cut or rasp cut file 1, water tube with water, compressor 1, pressure gauge 1, vulcanizing machine 1, tire setter 1, vulcanizing paste and patch as required, soap oil as required, waste cloth as required, and chalk powder as required. Check the valve core of the tire with soap water. If you notice any bubbles, then remove and replace the valve core. Next, check for the puncture in the tube assembly and get ready to dismantle the wheel. Check the opposite wheels using a wooden stock. Using a sledgehammer, tap the tire portion that is adjacent to the rim. Insert the tire lever in between the disc and beading of the tire and force it out to remove. Before removing the wheel, ensure that the wheel is well balanced on a jockey. Remove the tire nuts using appropriate tools. Remove the tire assembly and separate the tube. Load the tube with compressed air. Inspect the puncture spot with soap water and chalk powder. Mark the punctured spot using a marking device so that it is easily visible. If the tire is tubeless, then continue the above procedure without removing the tire assembly. After locating the puncture spot, reload the tube into the tire without air. Apply puncture cement or paste on the puncture spot. Place the patch on the puncture spot. Vulcanize the patched area using a vulcanizing machine. Once it is cool, reload the tube with compressed air and inspect the air leak with soap water. Refill air and assemble the tire. If the tire is tubeless, locate the puncture spot and dismantle the tire and rim assembly. Inspect the inner side of the tire assembly. Using a scuffing tool, rough the inner surface of the tire around the punctured area. If the punctured area is small, apply cement patch, and if it is larger in size, then cover with a patch. Apply pressure on the patch so that it sets properly. Reinstall the tire and rim. Ensure that the core valve is seated properly. After setting the rim assembly, hold the tire with compressed air. Inspect the puncture spot using soap water. Finally, Assemble the tire set onto the vehicle. In this video, we have learned to dismantle the tire and remove the tube, locate the puncture, apply patching cement on the puncture spot, assemble and inspect the tire and the tube. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will assemble and inflate tires with the correct tire pressure. By the end of this video, you will be able to assemble the tube and tire, inflate the tire to the correct pressure. Let us collect the tools, equipment and materials required for this. Trainee's toolkit 1, tire lever 1, hammer 16 pounds 1, wheel spanner 1, jack 1, compressor 1, pressure gauge 1, soap oil as required, cotton waste as required, French chalk powder as required. Assembling the tire and tube. Check the inner area of the tire for stones and nails. Apply French chalk powder on the inner surface of the tire and tube assembly. If there is any damage, then apply a patch on the inner area. Insert the tube into the tire. Inflate the tire to low pressure about 5 to 10 pounds. Insert the mouth of the tube into the rim and tighten using a valve tool. Insert the tire lever in between the beading and the rim and press the tire so that it sets correctly. Ensure that the lever does not damage the tire and tube assembly. Inflating the tube and assembling. After setting the assembly, tighten the valve core using an appropriate tool. Load the tube with compressed air based on the manufacturer's specifications. Inspect the tube valve core using soap water to detect any leaks. Assemble the tire and rim assembly using nuts and tighten them gently. Reload the jack slowly. Tighten the wheel nuts to the correct torque as per the manufacturer's specification. Remove the wheel choke or handbrake. In this video, we have learned how to assemble the tube and tire, inflate the tire to the correct pressure. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to check and correct tire pressure with the help of air or hydrogen. By the end of this video, you will be able to check and adjust the tire pressure using air or hydrogen. Let us collect the tools, equipment and material required for this. Trainee's toolkit 1, hammer 16 pounds 1, wheel spanner 1, compressor 1, pressure gauge 1, nitrogen gas as required, soap oil as required, wire as required and cotton waste as required. Before checking air pressure, let us identify and visually inspect the following. Identify the vehicle type. Identify the condition of the tire and its type. Inspect the tire tread flatness with the road surface. Any deviation in the tire tread should be corrected mechanically. After visual inspection, check the pressure using a pressure gauge. The pressure level should be as per the manufacturer's specification. Check the air pressure using air or nitrogen. If the pressure is low, fill up with the same media. If the pressure is high, lower it as per the manufacturer's specification. Ensure the tire pressure of all the tires is within the specified limit. In this video, we have learned to check and adjust tire pressure using air or hydrogen. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to rotate the vehicle wheels for minor repairs to the wheels and check dynamic wheel balancing and alignment. By the end of this video, you will be able to rotate the vehicle wheels and check dynamic wheel balancing and alignment. Let us collect the tools, equipment and material required for this. Trainee's toolkit 1, wheel spanner 1, jack 1, wooden blank 1, wheel balancing machine 1, air compressor 1, automatic wheel aligning machine 1, pressure gauge 1, soap oil as required, cotton waste as required, wheel balancing weight as required. Let us check the drive of the vehicle, that is four-wheel drive, rear-wheel drive or front-wheel drive. Gently lift the vehicle and rotate the wheels gently. Loosen the wheel nuts and lift the vehicle carefully using a jack. Mark every tire and remove it carefully. Inspect every tire for wear. Inspect the rim for bend or other damage. If the tire is in good condition, then check wheel alignment using a balancing weight. Wheel mounting on the aligner. Mount the wheel properly on the aligner as wheel balancing depends on how the wheel is mounted. Fit the suitable cone on the wheel rim with its conicity on the outside, ensuring that the wheel is locked completely on the hollow sleeve. Press the locking pedal. If the rim is made of light alloy material, replace the hollow cone with a nylon washer. Place the balancing wheel on the shaft and tighten. Ensure that the wheel is in line with the axis of the shaft. Tighten the shaft to the recommended torque. Check for dynamic balancing and alignment. Mount the wheel using standard mounting adapters. Select the required weight location by repeatedly pressing the Mode Select button until the location indicators display the exact location. Set the rim diameter knob as per the diameter shown on the tire outer wall. Set the rim width knob using a caliper. Set the rim offset knobs. Switch on the wheel balancer and spin the wheel. Locate and fix the balancing weight on the indicated imbalanced part. And in this process, the balancer will automatically calculate the weight required. In this video, we have learned to rotate the vehicle wheels and check dynamic wheel balancing and alignment. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will understand the tire wear pattern, identify its causes and provide remedial solutions. By the end of this video, you will be able to understand different types of tire wears, identify the causes for tire wear and find remedies to rectify tire wear. Let us collect the tools, equipment and material required for this. Trainees Toolkit 1, Pressure Gauge 1, Inspection Lamp with Guard 1, Wheel Spanner Set 1, Compressor 1, Jack 1, Cotton Waste as required, Oil Can as required. Let us look at the different types of tire wears that we can encounter. Rapid wear at the shoulder, rapid wear at the center, cracked tires, wear on one side, feather edge, bald spots and scalloped wear. We will now learn to identify the types of tire wear. A feathered wear pattern across both wheels indicates toe wear. An uneven wear pattern indicates camber wear. Irregular tire wear around the circumference of the tire tread indicate cupped wear. An uneven wear can also be caused due to the varied size of the tires. An overwear of the outside edges can be caused due to low air pressure. An overwear over the center of the tire can be caused due to high air pressure. Causes for uneven tire wear: underinflation or overinflation of the tire, lack of rotation of the tire, excess speed of the vehicle, excess camber, incorrect toe, unbalanced wheel or tire defect, misalignment of the wheels and suspension. Remedies for uneven tire wear: adjust tire air pressure to the specified level, adjust tire camber to the specified level, adjust toe to the specified level, balance the wheel dynamically and inspect suspension and rotate the tire periodically. In this video, we have learned to understand different types of tire wears, identify the causes for tire wear, and find remedies to rectify tire wear. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to overhaul the tandem master cylinder assembly and adjust the play of the brake pedal. By the end of this video, you will be able to overhaul the tandem master cylinder assembly and adjust the play of the brake pedal. Let us get started by identifying the tools, equipment and materials required. Trainee's toolkit 1, mallet 1, circlip plier inside 1, bench vise with soft jaw 1, vehicle with tandem master cylinder 1, master cylinder kit 1, kerosene as required, cotton waste as required. Dismantling the tandem master cylinder. Clean the cylinder assembly. Remove the reservoir cover with the diaphragm. Remove check valves and springs and drain the brake fluid. Remove the push rod and dust boot. Depress the primary piston slightly for removing the circlip. Remove the retaining spring and secondary piston with the primary cup. Remove the stop rod for removing the secondary piston. Inspection of the tandem master cylinder. Clean all internal parts with alcohol. Ensure that vent holes and ports are to be cleared. Check the cylinder bore for scoring, pitting, etc. Check and inspect both pistons visually for any scoring. Check the return spring and replace if necessary. Replace all rubber parts with new parts. Assembling of tandem master cylinder. Hold the cylinder in a vise with a soft jaw. Apply and clean the cylinder bore with brake fluid. Dip all the components in the brake fluid. Fix the return spring and the cup in a secondary cylinder. Fix the secondary piston and the cup using a spring. Press the secondary piston and fix the stop bolt. Fix the primary piston with the cup and spring. Fix the retaining spring and washer. Press down the primary piston for fixing the circlip. Assemble check valves with the spring. Fill up the reservoir and fix the cover. Press and inspect the free movement of the piston and fluid passage. Fix the dust boot and push rod. The brake pedal assembly adjustment. Check the brake pedal play and ensure that its range is between 6 mm to 12 mm. If it is not, then loosen the lock nut. Adjust the clevis. Tighten it if the play is more and loosen it if it is less. Again, check the pedal for free play. Tighten the lock nut when required so that free play is achieved. In this video, we have learned to overhaul the tandem master cylinder assembly, adjust the play of the brake pedal. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, We will learn to inspect and overhaul the front and rear brake assembly as well as the wheel cylinder assembly. By the end of this video, you will be able to inspect and overhaul the front brake assembly, inspect and overhaul the rear brake assembly, and inspect and overhaul the wheel cylinder assembly. Let us get the tools, equipment and material required for this. Trainees Toolkit 1, Socket Spanner with T-Handle 1, Wheel Spanner 1, Jack and Horse Stand 1, Flexible hose as required, Glass bottle 1, Brake fluid as required, Wheel choke 1 set, Cotton waste as required. Dismantling and overhauling the front brake assembly. Loosen the front wheel nut after chocking the rear wheels. Jack up the vehicle. Fix horses and remove the jack and wheel. Release the hub and the brake shoe assembly with the release spring. Remove the front bearing and oil seal and clean the grease. Clean all the parts with kerosene. Check and inspect the brake shoe lining retaining springs and the front wheel inner and outer bearings. Replace the part if there is any damage. Assembling the front wheel assembly. Clean the back plate assembly using kerosene and cotton waste. Fix and set the brake cylinder. Set the primary and secondary brake shoes with retracting spring. Fix the brake adjuster. Fix and set the shoe assembly. Loosen the brake adjuster and set the front wheel hub on the stub axle. Lock the brake adjuster. Fix and tighten the wheel with nuts. Fix the jack and release the horse from the main axle assembly. Dismantling and overhauling the rear brake assembly. Loosen the rear wheel nut after chocking the rear wheels. Jack up the vehicle. Fix horses and remove the jack and wheel. Release the hub and brake shoe assembly using the release spring. Remove primary bearing and oil seal and clean the grease. Clean all the parts with kerosene. Check and inspect the brake shoe lining retaining springs. Replace the part if there is any damage. Assembling the rear wheel assembly. Clean the back plate assembly with kerosene and cotton waste. Fix and set the brake cylinder. Set the primary and secondary brake shoes using the retracting spring. Fix the brake adjuster. Fix and set with shoe assembly. Loosen the brake adjuster and set the rear wheel hub on the rear axle. Lock the brake adjuster. Fix and tighten the wheel with nuts. Fix the jack and release the horse from the rear axle assembly. Inspecting and overhauling of the wheel cylinder assembly. Jack up the vehicle and remove the hub and drum. Disconnect the brake pipelines and remove the brakes. Remove the holding screws and separate the wheel cylinder. Remove the rubber dust boots and circlip. Remove the bleeder valve and clean all the parts with alcohol. Install the spring into the wheel cylinder. Install piston cups, piston and the dust cover using a circlip lock. Fix the bleeder screw and dust cap. Check piston clearance with a cylinder using a 0.05 mm feeler gauge leaf. Check the brake pipeline and connect. Bleed the system and inspect it. In this lesson, we have learned to inspect and overhaul the front brake assembly, inspect and overhaul the rear brake assembly, and inspect and overhaul the wheel cylinder assembly. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to bleed the hydraulic disc brakes. By the end of this video, you will be able to bleed the hydraulic disc brakes. Let us start with the tools and materials required for this purpose. Trainee's toolkit 1, flexible hose as required, glass bottle 1, brake fluid as required, wheel choke 1 set, cotton waste as required. Let us learn to bleed the hydraulic disc brakes. Clean the dirt around the master cylinder. Remove the filler cap. Fill the master cylinder up to the lower edge of the filler neck with brake fluid. Close the filler cap. Clean the wheel cylinder bleeder connection. Connect the bleeder hose to the longest distance of bleeder screw. Place the other end of the hose into the glass jar or bottle which is partially filled with brake fluid. Apply the brake pedal 3 or 4 times until it feels hard. Open the bleeder screw 1/2 to 3/4 of a turn and observe the jar for bubbles. Repeat this until only fluid comes out through the bleeder screw. Close the bleeder screw. Repeat the above steps for all the wheels. Fill the brake fluid again in the master cylinder. Close the filler cap. Close the filler plug and ensure that the bleeder screw is tight in all the wheels. In this lesson, we have learned to bleed the hydraulic disc brakes. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to overhaul and inspect the vacuum assisted brake assembly. By the end of this video, you will be able to dismantle and inspect the vacuum assisted brake system and assemble the vacuum assisted brake system. Let us collect the tools, equipment and material for this. Trainee's toolkit 1, circlip plier both internal and external 1, vacuum assisted brake system 1, workbench 1, cotton waste as required, soap oil as required and hydraulic oil as required. Dismantling the vacuum booster assembly. Chock the front and rear wheels and disconnect the battery. Remove the brake pedal return spring and connection. Disconnect the fork pin from the vacuum valve. Disconnect the hydraulic pipelines. Disconnect the vacuum line from the non-return valve. Loosen the mounting nut and take out the booster assembly. Remove the master cylinder. Dismantle and clean the booster. And remove the pivot assembly and diaphragm assembly. Remove segment retainer, set screw and spring guide. Remove the diaphragm disc and diaphragm. Remove the seal ring, lip seal and gaiter. Inspection of the vacuum booster assembly. Inspect all the parts for wear and replace if found damaged. Check the valve body, diaphragm and disc for any damage. Let us look at assembling the vacuum booster. Fix the retainer spring, disc and diaphragm into the valve body. Tighten the set screws. Fix the sealing ring in the operating rod. Drop the valve body gently in the rear housing and tighten. Fix the segment retainer on the push rod. Pull out the segments and check for proper sealing. Fold the segment retainer and secure the pivot assembly. Place the rear housing with the body. Fix the front housing along with the diaphragm return spring. Mount the booster on the vehicle with the master cylinder and connect the pipelines. Bleed and check the brake operation. In this lesson, we have learned to dismantle and inspect the vacuum assisted brake system and assemble the vacuum assisted brake system. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, we will learn to overhaul and inspect the hydraulic disc brake system. By the end of this video, you will be able to dismantle the hydraulic disc brake system, inspect the disc brake system and assemble the disc brake system. Let us get the tools, equipment and material required for this. Trainees Toolkit 1, Socket Spanner with T-handle 1, Wheel Spanner 1, Disc Puller 1, Micrometer or Vernier Caliper 1, Dial Gauge 1, Jack and Horse Stand 1, Air Compressor 1, Cotter Pin 1, Piston Seal 1, Banjo washers as required, brake fluid as required, cotton waste as required, wheel choke 1 set and emery paper as required. Dismantling the hydraulic disc brakes. Chock the wheels and loosen the wheel nut. Jack up the vehicle in support with the horse stand. Remove the wheel. Remove the caliper pin bolt, dust boots, cylinder slide bush, carrier bolt, disc brake caliper and carrier. Remove the disc brake pad, calipers, dust cap and bleeder screw. Disconnect the brake pipeline. Remove the cylinder boot, circlip, piston and piston seal. Inspecting the hydraulic disc brakes. Clean all the metal parts in kerosene. Check the pads, linings, slide bush, piston seal and disc. Replace parts if damaged. Assembling the hydraulic disc brakes. Fix the piston seal and insert the piston in the bore. Fix the cylinder boot, bleeder screw and bleeder dust cap. Insert the brake pads. Fix the disc brake calipers on the carrier and align with the bush hole. Fix the slide bush, dust boots, caliper pin, bolt carrier with the caliper unit. Fix the carrier with the caliper holder and tighten it. Connect the brake fluid and fill. Bleed the system. Adjust and test the pedal free play and check the brake performance. In this lesson, we have learned to dismantle the hydraulic disc brake system, inspect the disc brake system and assemble the disc brake system. Hope you have a clear understanding of this session. Thank you all and see you in the next video.
नमस्कार,